Hi students, I am Kamala Soppin, Assistant Professor of Physics at ARM Science College, Davangere. We are in the session 6 of Elasticity chapter. In this chapter, we are going to discuss the couple per unit twist of a cylinder and theory of torsional pendulum. After the completion of this session, you will be able to know the concept of twisting couple, the expression for twisting couple for a cylinder, then what is meant by torsional pendulum, the differential equation of motion for torsional pendulum, and period of oscillation for torsional pendulum. Then we will discuss about the couple per unit twist of a cylinder. Consider a cylindrical wire of length L, and here this is the cylindrical wire of length L, and area of this wire is A. Its upper end is clamped and the lower end is fixed with a rigid body. If you rotate the rigid body, then the other end is twisted. A twisting couple is applied to the lower end and perpendicular to its length. Then the radius O dash P, here we consider the cylinder in detail here. The radius O dash P here, the radius O dash P is here, like this, and that is going to twist. Okay. Then this point C is on the rim of the cylinder. Then the point P comes to the position P dash. Then this PP dash makes an angle phi here. Then this phi is the angle of shear. And due to this twisting couple and due to elasticity and restoring couple, equal and opposite to the twisting couple is produced in this case. Then the line CP on the rim of the cylinder parallel to O dash is displaced through the position CP dash. Here you observe this O dash is displaced through the position CP dash. Here this one, this position CP dash, through an angle phi here. Here phi is the angle of shear. The displacement PP dash is maximum for the points lying on the rim and decreases towards O dash. And here this whole cylinder is divided into number of cylindrical hollow shells of different radii. Here we consider one shell here, and the center of the shell is O dash, and we consider one circular shell here of radius x and thickness dx. Then from when the twisting couple is applied, the point P goes to the point P dash. Then from this one, the PP dash value is x into theta. From this diagram, this is x and this is theta. From this diagram, PP dash is equal to x into theta. And from this diagram, then PP dash is equal to length is L into phi. Okay. Then divide the cylinder into large number of coaxial hollow cylindrical shells. Consider a cylindrical shell of radius x and thickness dx. Then as we know, PP dash is equal to L phi from one diagram, and from another diagram PP dash is equal to x theta. Therefore, L phi is equal to x theta, or phi, the angle of shear phi is equal to x theta by L. Then the modulus of rigidity is defined as the ratio of tangential stress to shearing strain. The tangential stress divided by angle of shear, or the tangential stress is equal to rigidity modulus into angle of shear, that is equal to n into phi, and it is equal to n, phi is x theta by L. Therefore, tangential stress is equal to n x theta by L. Then face area of the hollow cylinder is given by 2 pi x into dx, that is the face area. The total force on this area is stress into area. Then the stress value is n x theta by L. Then area is 2 pi x dx here. Therefore, finally we have 2 pi n theta by L into x square dx. The moment of the force about the point O dash is equal to 2 pi n theta by L x square into dx into x, that is equal to 2 pi n theta by L into x cube dx here. Then the total twisting couple is given by integral of this expression between the limits 0 to a, because x is the radius, the minimum value of radius is 0 and the maximum value of radius is a. Therefore, the total twisting couple is equal to 2 pi n theta by L into integral of x cube dx between the limits 0 a, and 2 pi n theta it is divided by L, and integral of x cube is x to the power of 4 by 4, and between the limits 0 and a. Then after substituting the limits, we have the equation is equal to the total twisting couple is equal to pi n theta a to the power of 4 divided by 2L. And if theta is equal to 1 radian, then the couple per unit twist is given by C is equal to pi n a to the power of 4 by 2L. This is the expression for twisting couple or per unit twist. Twisting couple per unit twist is given by C is equal to pi n a to the power of 4 by 2L, where n is rigidity modulus and a is the radius of the wire and L is the length of the wire. Then we will discuss the torsional pendulum. This torsional pendulum is a system in which a wire is clamped at one end and whose other end is attached to a uniform body, like circular disc or circular metallic rectangular plate, etc. When the body is slightly twisted and left free, the system oscillates in the horizontal plane about the wire, and these oscillations are called torsional oscillations. And if I is the moment of inertia of the body about the wire and alpha is the angular acceleration of the system, then the deflecting couple is equal to I into alpha and restoring couple is equal to C into theta, as we discussed in the cylindrical wire, and where C is a couple per unit twist of the wire and theta is the angular displacement. In equilibrium, the deflecting couple is equal to the restoring couple. Therefore, I alpha is equal to minus C theta. This negative sign is used to show these two couples are in opposite directions. Therefore, we know that if theta is the angular displacement, then d theta by dt is the angular velocity, d square theta by dt square is angular acceleration. Therefore, alpha can be replaced by d square theta by dt square. Therefore, I is equal to I into d square theta by dt square is equal to minus C theta. Then c theta can be brought to the left hand side and it becomes positive. Therefore, I d square theta by dt square plus c theta is equal to 0. And dividing this equation by I, we have d square theta by dt square plus c by I theta is equal to 0. And this equation represents the differential equation for simple harmonic motion. And if is the differential equation for simple harmonic motion, the period of oscillation is given by t is equal to 2 pi root of I by c. The period of torsional oscillation is given by t is equal to 2 pi root of I by c. Then the questions of this session are: derive the expression for couple per unit twist for a cylinder. Then what is meant by torsional pendulum? Obtain the differential equation of motion for torsional pendulum. Write the period of oscillation for torsional pendulum and explain the terms. And these are some of the reference books. Thank you.